Hello, everyone. Welcome to today's really exciting webinar. We're going to be talking about probably one of our most anticipated feature releases in a really long time, and we're going to be talking about Path Explorer AI. So if you don't know me, I'm one of those voices you probably hear if you're on our YouTube channel. My name is Erin. With me today's got Matt, and we're going to step you through a whole bunch of sort of concepts and examples as it relates to Path Explorer. As usual, starting with like a little bit of an introduction and some concepts, and then we'll get into it with those examples. So our PowerPoint is freezing. There we go. Our content plan for today. To start, I'm just going to introduce sort of what Path Explorer is, a typical workflow for how you can set it up. We'll talk about some different concepts for controlling it. We'll discuss, and I'll show you the 4 different projects we're talking about today as examples, and discuss kind of what's applicable for using the tool with. And then I'll include the slightly less exciting limitations part, because we definitely want to highlight that. So that is our plan. Per usual, webinar housekeeping. Audience, you're muted, but that doesn't mean we don't want to hear from you. So if you have a question about Path Explorer or about version 11 or anything Roadeng related, please, pop open that question panel inside your question section of your GoToWebinar panel. Type your question. We'll tackle it at the end of the webinar, or possibly midway through. We've got a couple minutes with each path exploration that we've got some solve time, so we can address some questions there. And if you're watching this on the future off of YouTube, feel free to jot some questions down in the comment section. We can tackle those too. Okay, let's get into it. So to start, what is Path Explorer? So Path Explorer is an optimization tool that we have introduced inside of Roadeng's terrain module. So if you're familiar with some of our other optimization tools, those live inside of location. That is our detailed corridor specific module. Path Explorer is more of a landscape level tool, and it lives inside of terrain, and it's part of that Softtree Optimal add-on to Roadeng. Path Explorer really looks to find, optimized routes between 2 points, A and B, as you can sort of see here in this little graphic that I've got on the screen. And it takes into consideration a whole bunch of things, but the algorithm itself is really looking to minimize cost, to minimize earthwork costs, and to minimize surfacing costs, while meeting your project-specific constraints and standards. And some of those can include your grades, your side slope, your max cut and max fill depths that you're willing to have in the project, as well as look at these things that we call construction zones. We'll talk a little bit more about those in a few minutes, but those can include no-go zones. Maybe you've got an environmentally sensitive area. We can set that up as a no-go zone, or higher cost zones where, perhaps it's going to cost more to construct a road there. It's an area of rock. You can identify that with a polygon, and Path Explorer can then take that into account as it looks for your best alignments. So at the end result of this, within minutes, are alignment options. And I should put an asterisk next to minutes. Obviously, there is a little bit of variability depending on your project size. We're going to be showing you 4 examples today. Most of them are going to solve in the 1 to 3 minute range. I think, Matt, correct me if I'm wrong, one of them is about 7 minutes. We're going to maybe cooking show that, because you don't want to sit for 7 minutes, but it's a really, really fast tool. And hopefully you'll get to see that here today. In terms of a workflow, a little bit different than any of our other optimization tools. Again, this is landscape level. It's in the terrain module. So step 1 in the workflow is to create a tin surface. As long as you've got a tin surface and a feature which represents your A and your B, we're then going to go up into Path Explorer. You are going to select that feature. If it's currently selected, it should show up here using that auto checkbox. It'll use the current feature, or you can go and actually choose that feature you've created that represents your start and your end point. From there, we can configure our design parameters. This includes the number of outputs you'd like it to give. This can be anywhere from 1 to 10 paths. You can set up your curve radius, your minimum horizontal curve radius, I should say. You can define your road width. And this road width, Matt will show you a little bit more about it, but it is a simplified prism. The road width is actually including the ditches, which we don't actually account for in this level. It doesn't actually change the solution too much. So the road width, the width including ditches, and then it's some of your construction parameters, as I mentioned, your max cut, max fill, minimum grade, maximum grade, your cut slope and fill slopes. And then the algorithm uses cut costs, fill cost, and surfacing costs at a really simplified level, and it looks to minimize those. The other thing you can add into the path exploration workflow are things like construction zones, and a really great sort of example that what we typically see with Path Explorer is accounting for crossing costs with streams. And being able to, first use hydrology tools to locate those streams and ponds, and then being able to include an additional cost to cross those, whether that be, say, the cost of adding a culvert, or if it's a major stream or river, you might need to add a bridge. You're able to account for even a larger cost on that specific set of different polylines. So you can add those construction zones. And then you let Path Explorer run. And our typical, as I said, solve time a few minutes later, and we're going to get some optimized road locations. The next step after that would be, possibly going out, doing a field review, putting this into an Avenza map. And it really changes that question of, where should I put my road when you're out in the field, to why shouldn't I put my road here? And really helps to drive some in-field efficiencies. The tool itself, extremely thorough, allows you to start to compare and explore different alternatives. And you can also push it over into location to get it, even if you want to take it a bit further and get some even more detailed design information from it, from the office at this preliminary stage. So a couple concepts that we're going to talk about today that are really important in terms of, influencing, controlling how Path Explorer behaves. And the first of those is this concept of construction zones. So construction zones, there are 4 of them currently, with 2 more on the way. They really allow you to assign different costs and influence to the tool. So the first type here, as shown on the left, in my, I should say, pardon my kindergarten or PowerPoint drawings. These were made about 10 minutes ago, but first we've got the no-go polygon. So a no-go polygon will not let Path Explorer cross into it. So if there's a no-go polygon, the tool will exclude that area from its area that it's allowed to go into. Very similarly, you can do the same with a no-go polyline. You can't, the tool will not be allowed to cross that polyline. And then the more interesting one are the polyline and polygon zones. And these are zones where you can assign different costs. It could be a lower cost, it could be a higher cost, but there is a different cost metric that's being applied. And again, I'll show that in the example here on the left, for that stream or river that's being crossed, we could assign a crossing cost to that polyline or to a group of polylines representing streams. And then the tool will take those costs into account as it's reviewing the overall costs for the paths. Similar with a polygon, you can assign a different cost to that polygon. And then the tool will, potentially look to minimize if it's a higher cost, or maximize if it's a lower cost, the amount of time it's going into those zones. So really, really useful for controlling how the tool behaves. Lots of examples, that we can discuss here. We've got a great wetland example for you today. We're going to look at, obviously working with a lot of different polygons representing wetland. Streams and ponds, another one great example for working with polylines. But if you've got environmentally sensitive areas or geotechnically sensitive areas, you can account for those with polygons, either as no-go polygons or polygons of higher cost. The other concept we wanted to introduce kind of here in the upfront part is this concept of control points. So Path Explorer runs between A and B. But you can account for control points through multiple path exploration runs. You can then select the features you want. You can even join them and then take them into location as one feature. So some control point examples, if you've got a bridge site or a crossing location, or perhaps you're doing a wind farm, preliminary wind farm design. Obviously, those turbine locations are control points that we need to get to. With this, what we'd recommend doing is actually breaking it up. So having multiple features and running Path Explorer multiple times. And there's a function within Path Explorer to control your approach direction. That way you can ensure continuity as you're connecting your pieces together. So sort of instead of having the kindergarten drawing on the left, doing something like the A to B and then the B to C, and then connecting them together to move forward. In terms of project suitability, this is a greenfield tool. If you are working on existing infrastructure and you're upgrading it, please don't use Path Explorer. I don't think it'll be too helpful. But if you have, a greenfield project in steep terrain or wetlands or flat ground, and honestly, it can be anything. It doesn't have to be a road. It can be any type of corridor. We've seen clients use it for overland conveyors, pipelines, mountain bike trail design. You can leverage it for that. So we're going to go through 4 examples today. The first one up here on the screen is going to be our sort of steeper terrain example. We're going to keep it super simple just to let you know how it works. We're going to move into a complicated wetland example, figuring out what the best path to get through some really complicated flat ground that deals with a lot of water. Then we're going to move into a complicated steep terrain example. And we'll talk a little bit about, in a lot of detail here again, about working with those construction zones. And then finally, we'll give you an example of how to work with control points. And we'll use a wind farm example as that means. And with this one, we're actually going to take it and show you how we can do the whole process. And we'll see how fast Matt can go, especially because I've killed 12 minutes of webinar time with an intro. Quick limitations, really the only one I want to highlight here, this, although it's got the name AI in it, because it actually does have AI in it, it does not replace professional opinion. Roads are not meant to be designed by computers. They are meant to be designed by engineers with tools. And this really is just a tool in the tool belt that you can use to drive efficiency and cost savings in your project. And with that excessively long intro, Matt, are you ready?
I think so. We'll find out.
Awesome. Okay, I'm gonna make you the presenter.
And I'll just caveat with saying I'll probably end up going a little over my time, but I guess those of you that attend a lot of our webinars should start to expect that, I guess. I'm not good with that whole time we schedule.
I'm pretty sure we've never been under time on a webinar ever. So thank you all for being with us and hopefully overscheduling in your calendars.
Cool. And then one thing that I will just chime in with, aside from greenfield projects, it does work well on substantial realignments. So if you have the freedom to move your alignment around, works great. It doesn't have to be pure greenfield, but yeah, you don't. If you want your road exactly at a location, it's not going to be that suitable for it. Yeah, so I'm going to start out. We're going to run through a few examples. This first example that I have is a steep example, and it's a fairly simple one to start. We want to go from here up to there, and we are going to get there with Path Explorer AI. So just to start, I've got my feature that I want to use with my start point and end point selected. It's set to auto, so we're golden there. I can tell it how many paths I want to produce. And, well, I'm good with these default settings for this example, except I'm going to reduce my max grade a little bit here. So yeah, we're going to hit OK. And this thing's going to plug away and think. And of course, it's one of those things that for what it's doing, it's pretty quick, but it's not instantaneous. So we're going to watch this plug away for it shouldn't be too long. So right off the bat, it's telling us, well, it's found 5 paths. It's still looking for better alternatives. So if we let this run until, well, I was either out of memory or it looked at all the possible places to put a road, uh, it would stop and tell us that it has. This one's probably, well, we're probably not going to let it get that far. Eventually here, it's going to change to say, well, unlikely to improve. Oh, yeah, that was better timing than I could have asked for. So now it says five paths, unlikely to improve further. So we can hit cancel. We'll hit OK. And there we can see the alignments that it's found. And just kind of a little further explanation. So we've got our 5 possible paths. And these 5 possible paths, they're all within 10% of the cheapest solution. So yeah, that's part of the reason why we don't have something that's sweeping up over here. Well, it's not to say that you can't get there that way. It's just it's going to be a not very great solution. So it's giving you 5 most diverse solutions within that 10% cost. Let's switch gears. And we've got a really, really flat example. So we've got the ortho in the background. If we look at the 3D view here, we can see that there's not a lot going on. Now I'm going to just stretch this for the sake of saying, well, it isn't completely flat, but it's, if we just assumed dealing with all our dirt that we have to excavate for a road here is the same, well, the cheapest solution is going to be from point A to point B, just straight line. In reality, and if we just look at the ortho, we've got a bunch of wetlands, streams, etc., that we're going to have to deal with. So rather than just treating it all as equal, we're going to set up construction zones this time. And we could insert those. Now I've already got some inserted into my file here. I've got them just hidden for now. So rather than watching me bring in a bunch of polygons, I'm going to just unhide the ones that are already in here. So these polygons and polylines, they come from, well, they're publicly available, just come from a provincial database. I've got some stuff like this, which is categorized as a bog. Another nasty spot over here where we've got a freshwater marsh, a fen. So these classes, and this isn't to say do this, it's just we've got polygons. I don't want to go anywhere inside of these. So these are going to be my no-goes. Now this river here is, well, sizable. So I want that to be a fairly significant cost, but I've got some other things that are going to be less restrictive. So over here, we've got a forested wetland. Sure, it's wet, but I can probably build through it. It's not a no-go, it's just it's going to cost a bit more. So we are going to account for all this by setting up our defaults with that same UI that I used before. But we're going to include the extra with construction zones. So optimization tab. We could click construction zones to get to where we're going to go, but I'm going to do my defaults first in this portion of the UI. So this being flat, low volume road, I'm going to still plan to go faster on it than my last example. So I'm setting my minimum curve radius, my horizontal resolution. Rule of thumb, we want that usually at least a factor of 4 times smaller than the radius. Not too worried about my vertical in this. I'm going to reduce the resolution here. Number of paths, let's change it up. We'll go 3 this time. We're going to change our unit costs. So probably move dirt here if it's not sopping wet, fairly cheap. We'll include that. And my grades, well, there's no reason I'll have to go anywhere steeper than 8%. We'll switch over to construction zones, and we're going to, well, add in some no-go polygons. So these no-go polygons are all those bogs, fens, freshwater marshes that I mentioned off the start. So these we're not going there whatsoever. Polygons though. So let's go with shrub wetlands. So a little gnarlier than the forested wetlands. So I'm going to say, well, let's bump up our cost to deal with the earthworks for this. So it might take conditioning or extra handling. So we'll go 30, 30, and 10. We're going to do another set of polygons that are more than our default, but less than the shrub stuff. And we're going to account for some polylines. So these polylines are my water courses. These ones, we'll use the hydrology tools on the next example, but these ones, again, came from a provincial data set. And we'll hit OK. I'm going to also take it a step further here, and I'm going to say, well, I want that to start pointing in that direction. We'll hit OK. We'll ignore that warning, just some of those construction zones extend off my tin. And we'll let it run. So again, not instantaneous, but we can certainly let it plug away, and we'll get a decent solution here fairly quickly. And once again, it's telling us that it's found 3 paths. Again, I won't let this one run to the very end. I'm going to only let it run until it says it's unlikely to improve further. And there we are. So we've got our solutions, and I'll just highlight them so it's a little easier for folks to see. Yeah, at a glance, well, they seem to make sense. They're not spending a bunch of time in the really high cost areas. Where it's crossing here, it's at a bit of a pinch point. There, kind of same thing. But this one, without a doubt, looks like the more favorable, where we're just in those high cost areas for a short amount of time and running along the edge. So if we look at our 3D view, we can see, well, yeah, that totally makes sense. It's also crossing the, well, that kind of major crossing at a well-confined area. And if we want to look at, well, based off all those costs that we've added in there, is there a way to see how they're ranked? Well, if we click select feature by name, we can see the various Path Explorer features. And the number here indicates the cost based off the units that we've added in. So that one there is also the cheapest solution if we just look at the way it's scored in the algorithm.
And while you're in that one, Matt, I just wanted to highlight too, if you're wanting to see your full Path Explorer paths, our terrain surfaces in 3D are typically, fully opaque. So if you want to see what the path looks like, you can just go in and set an alpha channel to control that visibility. So it doesn't, you can get, doesn't look like a broken up road.
Yeah. So here it's under the surface. We've changed that. I'm also going to change that mustard color to be something a little easier to see. And there we are. And those lines that are extending off, I've just got some draped features that go off my surface. So yeah, totally can see through there. Next one, we've got steep and gnarly. So this is the one that I'm gonna cooking show it, where I'm not gonna let it run because it's gonna take more than a minute. Took I think 6 minutes to run on my computer here. But here, just looking at it, the ground's fairly complex. So right there, usually it's going to take a bit longer to solve than something that has an obvious solution. And switchbacks, if you require switchbacks, they generally take a little longer than just a straight shot A to B. Now, another thing that we can do here to help reduce the solve time is we can dump in, and we could draw it around too, but save watching me sketch, I'll bring it in as a feature that's already set up. We could say, well, we want to go from A to B still, but we want to set a no-go polyline to keep us within this feature. So that way the software's not wasting time looking way over here or way over here if we happen to know that, well, we don't want to go over there. So it's also really useful for things like if you had a property boundary and you wanted to stay in the limits of the land that you have access to. This one, rather than using streams from another source, I am going to use our streams and ponds tool. So we'll run this. And we'll set this up just as we did before. So I'll make sure I put the right numbers in, just you won't be able to watch the in between here. So 25, 10. This one, I'm going to reduce my horizontal resolution. I want it at least smaller than a factor of 4 of that. Resolution, reducing my resolution here, it's going to be largely dictated by the landforms. Grade, we'll go 18, 12. Good with that. Go to our construction zones. And while my streams, we want to be cognizant of our streams here. So if I didn't include my streams, I might get the alignment just going straight up a stream because it's the flattest spot. So all my streams, I'll go with the simplified approach here. Well, let's set our streams as let's say 5K. And that polyline, the no-go polyline, so that feature that runs around there, we'd set that. We'd hit OK, we'd hit run. And again, this one takes a little longer, a little more complex. So not all solve in a couple seconds, but we'd end up with a solution that looks like this. So looking at it, we can, again, right click by name. We can see, okay, well, that one there is running along, well, the one that is identified as cheapest is running along here. See, we've got a nice crossing there, switchback location that I never would have identified if I was clicking around by hand, I don't think. And then we ride the bench up to the top. So it's yeah, pretty solid result. We could go through piece by piece and look at these individually. We'll switch gears into our next one and we'll look at an example where we've got some control points. And this is the one that I will do right from scratch. just to walk through that whole workflow for folks.
And while you're getting that up, Matt, I'm just going to tackle one of the questions that came into the chat, which was asking about what the other two construction zones that I alluded to, what they are, and when they're coming in the future. So there are two of them. We've got a surface Z band, so that's controlling it by elevation, and a tin surface slope band, so being able to control ranges of your terrain by slope. Exact timing, unsure. It might be in a maintenance release of version 11. We're, still working through those details. Back to you, Matt.
All right. All right, so I've just brought in my LiDAR data. Yeah, so this is very much right from square one. I'm gonna model my tin. All right, and I'm going to click insert file. Now here, I could draw this in if I didn't know where I wanted to go, but I've got a shape file here with a couple points. Let's make these some color other than black. So this one down here is where I'd like to start. This one over here, or these two over here in this example, we're gonna treat it as wind farm example. Now there is some water that I'd like to account for here. So I am going to run the hydrology tools. And I'm going to tell it, well, I want to run from point A to point B. So, well, actually I'll create a new feature to connect the dots. That way it's just a little easier to see and we get that nice turbine. Set. So here, ultimately, I want to go from here to here and here to there. It's not set up to do that automatically, but we can do it in parts. So let's go over here. Now at the start here, my intersection, I do want that to be pointed the direction that I'd like. So I'm going to say at the start, we want to be pointed that way. Specs, wind farm example, I'm going to use a 50-meter minimum curve radius. We'll go with the old rule of thumb of divide that number by 4. Grades, it's not crazy steep, so there's no need to really push it. We could change our minimum specs if we'd like, but I'm happy with that. Now I'm going to include my construction zones for my streams. We'll make these 3K pop. And sure. So once again, we're waiting on the computer. Shouldn't be too long. But yeah, it's found 3 possible solutions, narrowing in on what ones are worth pursuing. Once that changes, we'll continue along. And there we are, unlikely to improve further. So we can see we've got that approach angle adhered to. Now this one being a wind farm example, I will look at my costs, but oops. So that one there is our cheapest. Well, I guess it just so happens. Here, I wouldn't have used that one just because here I actually want to be flat as I'm approaching in, so I'm going to use a little bit of a judgment call. I think that one's worth pursuing. We're going to go from there to the next point. So, current feature selected. We're going to run it again. Only here, I don't want to remove my existing points, so we've got that turned off. Construction zones, they're still there. I do want to control the direction that we come out of this, though. So we want that nice seamless transition. So we want to end up heading in that direction to start. And then as we come into the other approach, well, I don't really care about the direction of it, so I'll leave that unconstrained. And away we go. Now, this will be probably the last time I run it live here. So in this session, worth mentioning, I'm not getting too bent out of shape for my road width. So Aaron mentioned it in the intro, but we are using a simplified cross section here. So it's not including a ditch. It's not any complex slopes or crown or anything like that. So it's kind of, we're broad brushing it to keep it as simple as possible. So it's a solvable problem. So if it's the difference between a 10 meter wide or 12 meter wide prism, I'm probably not too worried about the granularity of that. And same with our cut and fill slope angles. Most of the time, I'm quite content running with the default settings here. Yeah, what's the best solution in terms of kind of that preliminary, where should we put it on the map goes? A lot of the time, these parameters aren't a make or break parameter to control. All that yammering on, we've got it set. We're going to hit OK. And we'll wait for the solution out of the, I guess, from B to C rather than from A to B.
And while that's solving, we do have a question related to this topic, which says, can we add multiple control points along the route? For example, a junction that we need to hit.
Totally. This is the way to do it. If you need to hit a junction, A to B in one go, and then B to C in the next go. Other common cases of bridges, if you have a stream crossing that is not a, well, I just want to cross it anywhere crossing, I want to cross it here, well, set that as your control point in the first run, and then tackle the approach coming out of it in the next run. And we've got our solutions. So I'm quite content using that one for my, well, next run. These, what do I do from the next side of things? I'm going to just highlight these, select by name. So we've got one that's quite a bit cheaper than the others. We'll see, do we like it? Sure, looks pretty reasonable to me. So here, before we switch this over to location, so we're looking at this as kind of that more complete workflow, I'm going to select both of those features and I'm going to hit Control J. So now they're treated as one. We are going to hit File, save as. We're going to save this as topo. And we're going to fire up location.
And now we get to see if Matt can take this to a full geometric road design in 5 minutes.
Well, I think we should be all right. Yeah, so referencing my terrain file, just as we would with any other road edge workflow. I want my initial alignment here to be the feature that I had selected. So we'll run with that. And we've got something largely started. Now I want to take this and I want it to be a proper alignment rather than a polyline. So right now we can see each one of those turning points is a vertice. I don't want that. I want proper curves. So I'm going to go over to corridor, polyline to alignment. We'll call our minimum radius out. We're going to give it a little bit of tolerance to straighten some things out. And we can see we've got our alignment there. To actually design in our vertical, well, we can tackle that. So we're going to do this with the vertical optimizer. Put in our design constraints. And here I will mention this example that I'm showing. I'm kind of doing it off the cuff as a wind farm example, but we can be much more complete at the expense of a couple extra minutes here. So we could include the actual pads next to our turbine locations with crane laydowns, all in our earthworks. And with that, I'd probably reduce my grades at those sites as well too. So we don't have crane laydown on 12% grade, for example. We'll add in some control points. So I want a control point at the start of my road. I want a control point at the end of my road. And we'll keep that 4%. Again, kind of for coming into a pad, we want to keep it reasonable. Oh, and I forgot to hit add edit there. So we've got that. And yeah, we could add another control point at our turbine location. So if we want to be right at that elevation, or plus and minus a little bit at that elevation, we can do that here too. So at station 1028, we want to be plus or minus 2 meters. And we want to be fairly flat going through there. We'll hit process. We'll let this thing run. And once again, not instantaneous, but it's going to figure out a pretty hard problem here fairly quickly. And yeah, we're at a point where we're waiting for the computer again. We can probably take a question here while we wait.
Totally. And then I might just quickly recap what you just did in the last 10 minutes. So Matt loaded up a terrain, brought in his project data, figured out the preliminary location for 2 sections of road between some turbines, brought it into location, turned it into an alignment with curves, which wiped out his profile. And now what we're waiting to solve is that optimized profile. And we didn't really talk about this much because this is obviously a webinar on Path Explorer, and we're just trying to give you a quick little rundown on the workflow. But this profile optimization is a much more detailed optimization when it comes to earthworks. And I noticed one of the questions in the chat here is asking about earthwork costs. But the earthwork costs for this one are, again, much more detailed. They're cross-sectional areas. And perhaps, Matt, if you have a second, you can circle back and talk to the earthwork costs inside Path Explorer and then how that's differing from the earthwork costs on this geometric design.
Totally. So in Path Explorer, the earthworks costs that we're accounting for are really just cut and fill cut. Well, actually, I can open this up while we wait here. So we got our cut costs, so dollars per cubic meter, and then we've got our fill costs, so dollars per cubic meter, and then we've got a cost for surfacing. So this would be kind of your pavement costs, and I'll put that in air quotes a little bit, which is dollars per square meter. The reason I'm putting that in air quotes is it doesn't have to be a proper asphalt surface or anything like that. And even if you're just running with a subgrade road, prepping that road surface does take a little bit. So it's best to include something in there that's representative of that prep cost and the aggregate cost for building out whatever you have planned. Whereas if we look at the costs in location, we're including the excavation costs, we're including the fill costs or embankment costs. We can include the per cubic meter costs for your pavement material if you like, but the big difference here that adds a lot of realism to it is we're accounting for the haul. So the actual material that's required to, well, build a fill like the one we have presented here, which is not a trivial fill. Well, it has to come from somewhere. So in location, we're accounting for that haul cost. That's, well, here we can look at our mass haul. We see we're generating some cut, and that's getting moved into account for that fill here, and same with the other side of things. So it's the cost model and location is much more complete, but it's a big problem, and keeping it as simple as we can in the Path Explorer phase makes it so we can solve the problem fairly quickly and still give reasonable results. We've stripped out all the complexity that we can and still get good results, and then kept the complexity that's required to give something that's meaningful and real. And with that, our vertical optimization's done here. We can see what we're dealing with. We've got our vertical alignment accompanying our horizontal alignment here. We can fire that up in the 3D view, and yeah, makes sense, looks reasonable. And of course, we could add our culverts in and our, well, take it to multi-plot and produce our documentation. But I think the proof is in the pudding, and I'll leave that here for the gist of it.
Awesome. Well, thank you, Matt. Thanks for tackling this webinar well sick. We're going to get into the questions. We're only 4 minutes over, so I'm decently impressed with us. Before we get into the questions, reminder, if you have one, type it into that question section of the GoToWebinar panel. You are anonymous. I did just want to say thanks. I know we've had some time zone changes with the whole daylight savings thing, making it a little bit harder for some places in the world to join us for webinars. So I think we have representation from 6 different continents right now. So for those of you who are sacrificing sleep to be here, to join us live, thank you for that. We really appreciate you taking the time to be with us here today. For those of you, India, Australia, Bangladesh, all of Eastern Europe, the UK, Ghana, South America, anyone who is literally, not, obviously South America is not, but who's sacrificing sleep, thank you. Questions. There's a whole bunch here in the chat. So let's attempt to tackle some of them. The first question, Matt, is it possible to use Path Explorer to analyze a road in terms of cost per linear meter instead of dollars per cubic meter? Because that's how they do their road costing.
Okay. So it's not set up to work that way, which might seem disappointing at a glance, but it shouldn't be too much of a barrier if you're not used to thinking about costs in dollars per cubic meter. So the reason for that, and it's kind of, well, you might be able to look at a chunk of topography and say, well, it's only going to cost me this much to build a road across that. In actuality, if you were laying that out, you're probably taking into a lot more kind of nuances. And if I was plowing through this little hummock here, well, plowing through that little hummock there, it results in moving more dirt. So if you were laying this out by hand, you'd probably avoid going through that hummock. But if you're costing it in terms of dollars per linear meter, you might not capture that difference. So that we do need to consider it in terms of dollars per cubic meter to get a reasonable solution. Now, the saving grace of all this is these numbers can be pretty wacky numbers and still get reasonable solutions. So the gist of that being is the cheapest solution is going to be one that moves the least amount of dirt. So if my number is $12 a cubic meter for cut versus $3 a cubic meter for cut, as long as these are proportionally reasonable, I have some idea that my cut's going to cost, well, in this case, more than my fill. A lot of the time for me, it'll be kind of the other way around where it'll be numbers like that. If we ran this again, we're probably not going to get something that's drastically different solution. Yeah, so considering dollars per cubic meter, short answer, or sorry, considering dollars per linear meter, short answer is no, it's not set up that way. But it should still be easy to work with, and you'll, even if you run with this at the start and compare the numbers to what you get if you just eyeball it and apply a per linear meter cost to it, you should find out that you're still getting great results. So hopefully that answers your question.
Awesome. The next question, obviously, staying inside of Path Explorer, because that's the topic of the webinar. Are we able to see preliminary costs and possibly some other text-based data inside of terrain before we choose a path to swap to location?
So preliminary costs, yes. So select by name. We can see this guy here. So yeah, that number that comes after is going to be your cost. In terms of text-based feedback, I'm not sure completely what you're looking at for that, but we could compare the length. And now I've already joined these, but we can select that feature here. So we've got our length down there. So that's 900 meters versus that's 1,027. So if we want to just get quick metrics of what we're dealing with, we can. So we can look at that in our fields. We could customize what's visible here through our attributes. If we wanted to take a quick glance at one of the profiles that we're working with too, we could look at the profile in terrain, and we could add in labels if we wanted to see labels for our grades. So yeah, we can see things like that, but yeah, hopefully that answers your question. It won't give you a printout for text on some kind of score automatically, but you can populate the a lot of the pertinent parameters with your status and adding labeling in to see things that you'd like to see.
Okay, let's do one maybe two more. How can I determine what horizontal and vertical resolution is acceptable for my project?
Okay. So let's crank this up to 50. And it gives us a warning. So if we go with a number that doesn't really match well between this and this, it's going to tell us that, well, maybe we'd like to reduce it. Rule of thumb, reducing this by a quarter is, or sorry, making your horizontal resolution a quarter of your radius or less generally gives pretty good results. The other side of that is that resolution is the smaller the number, the more accurate, I guess, the software is going to interpolate the terrain surface that you're looking at. But it does come at a performance cost. So if I go with a really small number in my horizontal resolution, the problem size gets a lot larger, and we're going to have to wait a lot longer for things to solve. So there's a little bit of a trade-off there. Yeah, generally kind of rule of thumb, less than a quarter of that number. I usually don't go any higher than 20 meters. If it's really complex, gnarly terrain, where there's a lot of detail that I want to account for, I may reduce that. I usually don't end up going any less than 5 meters. But then there's a trade-off. If you're dealing with really large projects, say 50 kilometers, well, I might start out with a really coarse resolution to start with to get a feel for the, well, at a coarse level, where should we put the road, and then, well, rein that in afterwards. And we've got maybe worth pursuing over here, over there, and clip out our tin surface so we aren't considering the whole problem for those really large problems. Hopefully that answers the question.
Awesome. Last question, and maybe Matt, I'll get you to keep hovering there on the Path Explorer button. This question is, can I download a trial for testing this Path Explorer tool? And when Matt was hovering over on the ribbon on top of the Path Explorer button, it did say that this is an exclusive support feature. So I feel like a bit of a buzzkill saying this, but Path Explorer is available only for clients, only for those of you on support. If you are interested in a trial, our best solution is to just set up a quick 15-20 minute demo. We can load up your project and step you through it. If you're interested in that, we will include a link in the YouTube video as well as in the follow-up email for how you can get in touch with us to arrange that. But yes, unfortunately, Path Explorer is not available in trial, nor will it be in the future. We're going to continue to reward our support clients with really rad features. On that note, we're going to wrap it up there. 15 minutes over. So thank you again for your patience and constant patience with us as we always run over time on our webinars. We hope you really enjoyed this new feature preview for Path Explorer. We're super pumped about the tool and hope you are too. And if you have any other questions, please do reach out to us, support.team@softtree.com. Have a wonderful day ahead, everybody. And thanks, Matt, for doing the sick.
Cool. Well, thanks everyone, and sorry for my voice for those of you that might struggle to hear me. But yeah.
Awesome. Bye, everybody.